A key component of our changing weather is a result of the heating and cooling of the land, the sea and the air. This change enables the development of clouds, and the principles of their formation are applicable to the phenomena we're going to be discussing in the next sections of this course. So in this section we're going to be discussing how clouds form and the types of clouds we can expect to see. Clouds play a big part in photography, and they can certainly make or break a photo. It's invaluable to understand what types of clouds we can expect to see from a forecast, as it can help you in deciding what to go photograph, whether it be lakes, coasts, mountains, rivers, forests or whatever. They can also be the driving force to keep you going out and reshooting a location time and time again, or maybe a specific composition, as each time will be different than the last, giving you the opportunity to capture something really unique or even build a portfolio from a location. Here is an example of a fantastic set of images from a friend of mine called Ryan Harris, who's also a brilliant photographer. He's been photographing this same scene near his house for a few years now. You can quite clearly see how not only these are brilliant images on their own, but as a collection or a portfolio they're so impactful, showing how dynamic and changeable our weather really is. Throughout this course I'll refer to what is known as the troposphere. This is the atmospheric layer which forms the first 60,000 feet, which is about sort of 7.5 to 10 miles from the Earth's surface, depending on your latitude, and for our interest, where most of our weather actually occurs. To put that into perspective, Everest is around 29,000 feet and planes fly at around 33 to 42,000 feet. As you'll notice, you're always above the clouds at a maximum flight altitude. Beyond this layer, there are other atmospheric layers such as the ozone layer, but for the purpose of this course we're only interested in the layer associated to our weather. The first explanation for the development of clouds is because of the sun. The land changes temperature more quickly than water because land has a specific heat capacity which is lower. In simple terms, it takes less energy from the sun to raise the temperature of the land, which is why sand on a beach can be really hot and pretty much feel quite cool when you're in the sea. Therefore, during the day, the land gets hot and the air above it then heats up and hot air expands. It becomes less dense than the cold air, causing it to rise. This creates an area of high pressure above due to the movement of air upwards. Air moves from areas of high pressure to low pressure through what is known as convection, or simply where there is lots of air to where there is less. As we know, the sea is heating and cooling less than the land. So here is the movement of air will be out to sea, where there is low pressure. This movement of air now means that out at sea it is accumulating and creating downward pressure where there is more air sitting on top of its surface. This creates higher pressure at the sea level. And as we know now, air moves from high pressure to low pressure, creating winds close to the surface and moving air back to the land where it is low pressure at the surface. Remember, the air at the surface of the land is heating and rising, and this is why we have low pressure at the surface. This action is also the principle of how our winds are formed. So where we are starting off with just a change in temperature, we now have movement of air in a system. An easy way to remember this is that change in temperature creates change in pressure, which creates wind. The air that comes back from the ocean has now absorbed moisture. So as it rises again over the land, it starts to cool. Its density increases, meaning it can't hold as much of that invisible water vapour, and it causes it to be forced out in the form of tiny liquid particles which become clouds and rain. This phenomenon also happens on a much larger scale between the equator and the North and South poles, and is responsible for global atmospheric circulation. The equator undergoes much more intense heating, where the sun hits it at a higher angle. The air rises and moves towards the poles before it gradually sinks, creating big spinning circles of air. The dry sinking air that creates high pressure leads to clear skies and desert climates. The air returning to low pressure areas picks up moisture and then leads to rainfall and creates tropical climate. This is why we have distinct bands of tropical climates and desert climates across the Earth. Obviously this does get even more complicated due to the intensity of sunlight, reducing the further north of the equator you go. And this is what splits the global circulation into multiple cells or layers. This also shifts throughout the year too, as the Earth changes tilt. And as we all know, this is why we have seasons. The spinning of the Earth then causes these movements of air to bend and turn, and this is what creates our prevailing wind directions. Here in the UK it is westerly, and you can see that the rotations are mirrored across the equator. This is similar to why water spins down a plug hole and rotates in the opposite direction if you're in the southern hemisphere. So to summarise, our global as well as more local weather systems are created through the heating of the land by the sun. This same principle will keep coming out through this course. So remember, change in temperature creates change in pressure, which creates wind or convection. The cycle of dry air and moist air, heating and cooling and moving through the atmosphere is what develops our clouds. Because, as we know, air cools, it can hold less water vapour, which becomes forced out as liquid droplets. But what happens when these large air masses meet, where cold masses meet warm masses and vice versa? We'll be discussing this in the next section. Weather fronts can also form clouds, where a front is the meeting of cold and warm air. Here warm air is forced above cold air, causing it to cool, and water vapour is forced out. In the UK, most of our weather fronts form out at sea over the Atlantic and move from west to east in the direction of our prevailing winds. You can see the boundaries between high and low pressure systems on Ventusci, under the pressure map layer, and the indication of its direction through the streamlines on the map. On traditional weather reporting, you've probably seen lines and symbols for a weather front. A cold front is symbolised with a line of blue triangles. These show the position and point in the direction of cold air, advancing and pushing under warm air. Due to the greater density of air in its wake, cold fronts can move quicker than warm fronts. And as we know, cold air is denser than warm air, and this forces the warm air above it. These fronts can bring about thunderstorms, rain and hail. Warm fronts are shown with red semicircles. These show where the warm air is advancing and rising over the cold air, as it is less dense. Occluded fronts, they're a little more complicated and are shown with both semicircles and triangles. These occur when cold front catches up and overtakes the warm front. The warm air is lifted from the surface and is therefore hidden or occluded. Another way clouds can be formed is where warm, moist air being forced upwards by mountains instead of over a cold front. This causes the air to cool and form clouds. This is why you often see clouds clinging to the sides of mountains, particularly on the windward face. So there we have the fundamentals of how our clouds can form. We know already that our weather apps split our cloud levels into low, medium and high cloud. And depending on the combinations of the cold and warm air fronts, it leads to the development of different types of cloud. In the next section, we'll look in more detail at the types of cloud we can expect to see, as well as their distinct characteristics that make them special. After all, it's these that will make your images really special. There are three types of cloud levels to consider in terms of what the apps display, and that is low cloud up to 6,500 feet, medium cloud up to 20,000 feet, and high cloud beyond this up to the top of the troposphere. We've seen these already when we looked at the cloud layers in Ventusci and Clear Outside. Low cloud is anything up to 6,500 feet, which in most instances is associated with rain, and it can give a lot of drama to your photos. These clouds generally form on a cold front where warm air is forced above. Cumulus and stratus clouds form at this level, and in particular cumulonimbus, which you may have heard of, and these possibly the most interesting. Cumulo meaning heat and nimbus meaning rain. These are generally the formations of storms as water vapour is forced out of the lower troposphere and is carried upwards by buoyant air currents. These also bring about thunderstorms. The cumulonimbus clouds here can extend the full height of the troposphere. Nimbostratus clouds can extend across medium and low regions. With their base in the low region, they are generally seen as dark, featureless clouds with light to medium rainfall. These occur when warm air passes over a cold front. Medium cloud ranges between 6,500 feet and 20,000 feet. The two main types of cloud here are altocumulus and altostratus. Alto meaning medium, stratus meaning flat or smooth, and cumulus meaning heaped up and puffy. Depending on the time of year and altitude, these clouds can be formed from liquid droplets, or ice crystals, or combinations of the two. These types of cloud are formed where a warm front of air passes over a cold front. Above 20,000 feet, you get high cloud. These form at the very top of the troposphere, where it is the coldest. These result in clouds forming of supercooled water droplets and ice crystals, which makes them appear quite wispy. These are generally seen as cirrus clouds. These types of cloud are formed where a warm front of air passes over a cold front. So that concludes this introduction to the formation and types of clouds. Remember, the differences in heating of land masses to ocean masses creates change of temperature. Change in temperature creates changes in air pressure. And changes in air pressure creates movement of air, known as wind. These systems are extremely complex and are impacted by numerous other factors, such as ocean masses and their currents between the land masses, changes in topography, such as mountains, and also how the sunlight hits the Earth, such as the change in tilt of the Earth throughout the year. And this is why we know we have seasons. And even the Coriolis effect, which is the movement in air of water due to the spinning of our Earth. This is why hurricanes spin, and also why water spins down the plug hole. Thankfully, our weather apps do most of the thinking for us, but it is important to understand the types of cloud we might see depending on the warm and cold fronts around our high and low pressure systems. Our weather apps and services also give us indications of the percentage coverage of each of the low, medium and high cloud levels. So it's worth bearing these in mind when planning a photograph in terms of what type of cloud will be visible from the ground or your intended viewpoint.